Presenting you Stark Industries represented by Ishrat, Hunter, Manny, and Pooja. The big final competition is based on the matrix where we have a 7-foot by 7-foot arena with 4 home zones represented by the different colors yellow, black, blue, and white. At the center of the arena is the rotating matrix with Mr. Morpheus right in the middle on top. The starting zone, represented by the 30-inch by 30-inch rectangles, is where the machine is to be placed and launched, and the machine is to fit within a volume of 1 foot by 1.5 feet by 2 feet, as represented by the white box. The objective of the competition is to score maximum points by accomplishing a set of task requirements. Here is the house of quality that provides a better understanding of the problem and what is required of the machine in the final competition. The most important engineering requirements as shown here are the failure ratio, which indicates the number of acceptable machine malfunctions at 1 failure per 30 runs, and points earned. The most important customer requirements include repeatability of task completion, ease of boxing the machine, indicating it meets volume constraints, and scoring maximum points.
Shown in Figure 2 is the function tree of our project, which highlights the 4 major functions and their respective subfunctions. The easiest function is moving the programming modules, as it involves the modules being moved by a very small distance, and perhaps the hardest functions are blocking incoming sentinels, preventing retrieval of programming modules by competitors, and preventing competitors from retrieving Morpheus first. These functions involve the machine's interaction with those of the competitors and implies that the machine has to accomplish these tasks speedily before a competitor does. Here is a morph chart for the final machine. It shows the possible solutions for each subfunction. Possibly the hardest subfunction to achieve is identifying the red zones where the red pills are to be deposited. And several solutions for this involve using IR sensors and switches to detect the beacons.
The first concept alternative, or the collinearity, features an extending arm that pushes the sentinel into the EMP blast zone and extending arms that swing over the programming modules and push them into the home zone. Drawer sliders extend the pills and Morpheus subsystems where the pills are deposited by pipes, and when the solenoids are activated, the red zones are detected by means of an IR sensor. A retractable extending arm captures Morpheus when triggered by a mousetrap.
The first design alternative features simplistically designed subsystems that are intended to be robust. Working from top to bottom, the Morpheus retrieving arm consists of a lobster loop-like grasping mechanism fabricated from a sponge that is then constricted. The pivot arm can then be retracted to the Haven of Zion. Underneath the retrieving arm platform, 2 pill deposit tubes are fastened side by side. A retractable Sentinel bulldozing arm located on the base is flanked by 2 module capturing arms that bring modules back into the home zone.
The second concept alternative is the Mi-Robot. The Mi-Robot uses retractable arms powered by pneumatic actuators to collect the programming modules by knocking them into the home zone. A retractable arm hooks onto the Sentinel and brings it to Zion when pulled by the string and motors. When the drawer sliders fully extend, a roller switch detects the beacons corresponding to the red zones and deposits the pills when the solenoid is activated. Morpheus is captured by a net attached to a retractable arm that can later be rolled back with the entire secondary platform, bringing Morpheus back to Zion. The third concept alternative, the Dreamcatcher, makes use of gravity-powered sweeping arms to collect the programming modules. A hook is launched over the Sentinel by a pneumatic actuator to capture the Sentinel. Drawer sliders extend the secondary platform closer to the EMP zone, which allow Morpheus to be captured. A retractable arm containing a Dreamcatcher-like pattern of zip ties entangles Morpheus and brings him back to Zion. While the secondary platform is extended, a roller arm switch clicks against the beacons to detect each zone of the EMP blast zone and deposits 2 pills in each red zone. The next concept alternative, the Sagittarius, uses drawer sliders as well to approach the EMP zone. Morpheus is captured by a grasping mechanism and brought back to Zion via string and falling weights. Simultaneously, a roller arm switch differentiates the red and blue zones and deposits 2 red pills in each red zone. The Sagittarius also uses 2 pneumatic actuator-powered retractable arms as well as a sweeping arm to collect the programming modules and expel the Sentinel out of the home zone.
This third-level evaluation matrix illustrates the prominence of the Mark 42 design. Easy to box and repeatability of task completion criteria both scored highest with a rating of 4, while also having the highest importance. Designs such as the Dreamcatcher and the Sagittarius scored very low across the board due to complex subsystems that contained several moving parts and functioned inadequately. With similar design aspects to the Mark 42, the collinearity design ranked second with a high relative total. A high relative total among machines with similar designs signifies strong subsystems and robust designs.
In order to create a final machine capable of performing all the required tasks, it's important to take into consideration all the requirements and constraints. Through analysis and testing of the multiple design alternatives, we arrived at Mark 42, which performed all the 4 tasks simultaneously. Some important points that we took away from the design evolution process so far is the significance of testing the machine because of the different volume constraints that the final competition requires. In addition, the results from previous competitions show that aiming for all 226 points per round is tricky, and it makes more sense to concentrate efforts on certain tasks. Going forward, design testing will be a lot more important as past failures occurred mainly due to tolerance issues and the low level of design execution.
Thank you for watching.